Okay, so in the last video we talked about the concept of acceleration, and we did some examples with that. Remember that by definition acceleration is defined as the rate at which an object's velocity changes over time. Okay, and so usually when you think of something accelerating, you think of it speeding up or slowing down. Okay, and so we did some problems, doing really basic calculations with acceleration. We talked about how the unit of acceleration is meters per second squared, because it's basically like meters per second per second. The value for acceleration tells you by how much the velocity changes each second. Okay, that's why the unit is meters per second squared. Okay, so in this video, we're going to talk about how to solve problems with constant acceleration using equations. Now, in the past, when we did problems with constant velocity, we used the constant velocity equation, which looks like delta x equals v times t. Okay, and that's a really simple equation because constant velocity is the simplest type of motion you could possibly have. So we have one simple equation for constant velocity. Okay, that's the equation we have here. And now we're going to introduce the equations for constant acceleration. But because acceleration is a more complicated type of motion, because it involves a change in velocity, okay, instead of one equation, there's three equations. And these three equations are more complicated, as you can see on this slide, compared to the constant velocity equation. Okay, it's really important that you understand how to use these equations. We are going to be using guess method to solve problems. And remember, guess is something that's meant to help you out, to give you kind of like a roadmap for how to approach these problems. Okay, so here are the three equations that we're going to be using to solve problems with constant acceleration. The first one, we have Vf equals Vi plus At, and here I'm just going to kind of write out what all the different variables stand for. Vf stands for final velocity. And the reason we have a final velocity now is because the velocity of the object is changing. If you are accelerating, that means your velocity is changing by definition. Okay, so the problems we're going to be doing with this have two velocities, an initial velocity and a final velocity. Okay, so the final velocity, Vf, is the velocity at the end of the problem, and then Vi is the initial velocity. Okay, that is the velocity at the start of the problem. Now, velocity is almost always measured in meters per second. Okay, so the unit for velocity is meters per second. So if you see something is measured in meters per second, you don't know what velocity that is without reading the question carefully. Okay, so you're going to have to use context clues to figure out, is this velocity the final velocity or is this velocity the initial velocity? Okay, we also have A, which A is acceleration. That's what we've been talking about in the last video. And acceleration is always measured in meters per second squared. Remember, acceleration tells you by how much is your velocity changing by every second. Okay, and then we also have time. Okay, t is time, and that's measured in seconds. Okay, that's an S. It's just a bad-looking S. Okay, so time is measured in seconds. And then delta x, we've seen before, delta x is displacement. Okay, and so we have three equations. There's 5 variables. Displacement is measured in meters. Okay, and so you need to understand units. Okay, you need to be able to use units to identify what a given variable is. Okay, and you need to be able to figure out which equation to use. Now, I'm going to tell you exactly how to do that, and we're going to do lots of examples. Okay, but remember that when you use guess to solve a problem, okay, you first identify your given, then you figure out your unknown, and then you pick the equation. Okay, so notice we have 3 different equations here. Make sure you write them down because we're going to be using them for all of these problems. Okay, so make sure you pause it here and write all of these down in your notes. Okay, but people always ask me, how do I know what equation to use? You must find the givens and you must find the unknown before you can figure out what equation to use. Okay, that's why it's guess. Okay, given and unknown come first. You have to do the given and unknown first. And the reason you have to do this first is because you don't know what equation to use until you figure out your givens and your unknowns. Now, in all of these problems, you're going to have 3 givens, 3 pieces of information that you're given in the problem, and 1 unknown. And once you have those 4 things, then you can figure out which equation to use. Because if you look at each of these equations, each equation only has 4 variables in it. Okay, so as soon as you have your 3 givens and your 1 unknown, then you can choose which equation. Okay, so you shouldn't be asking which equation should I be using, because once you have your 3 givens and once you have your 1 unknown, there's only one equation that you can use. Okay, because there's only one equation that's going to have those exact 3 givens and that unknown. Okay, so please pause it here, make sure you have all this down. We're going to do some examples with this. Okay, but it's really important that you understand that you must find the givens and the unknown in the problem before you can do anything else. Okay, so pause it here, get this down, then we're going to start some examples. Okay, so let's take a look at some examples. Okay, and actually before we do some examples, there's something I want to go over really quickly. Okay, because for the first time, we're going to have to do more algebra and really use our algebra skills in order to solve some of these problems. Okay, once you plug in numbers into your equations, you're going to have to rearrange your equation and solve for your unknown. Okay, now you should know how to do this from your algebra classes. Okay, but let's just kind of recap. Okay, let's say you have an equation and your equation has an unknown. Let's say the equation is 3x plus 5 equals 23. Okay, so let's say this is our example. In order to solve for x, you need to first identify what mathematical operations are being done to your unknown variable. Okay, so in this example, 3x plus 5 equals 23, there's 2 things being done to x. Number 1, it's being multiplied by 3. And number 2, it's being added by 5. Okay, so that's the first step in solving for an unknown. Next, you're going to undo each of those things being done to your variable by doing the opposite operation. And when I say the opposite operation, what I mean is, for example, addition and subtraction are opposites. Multiplication and division are opposites of each other. Squaring and square rooting are opposites of each other. Okay, so you're going to undo each of those operations one at a time, okay, in order to get your variable by itself. Okay, but there's a specific order that you need to do that in. Okay, so the order is this. Okay, so you should have learned about PEMDAS in the past, the order of operations. We're basically going to do PEMDAS backwards. Okay, we're going to use what I call SADMAP. Okay, SADMAP would be subtract, add, divide, multiply, exponent, parentheses. Okay, and SADMAP tells us the order that we should use in order to undo mathematical operations to solve for our unknown. So here's an example. 3x plus 5 equals 23. What's being done to x? It's being multiplied by 3 and it's being added by 5. Okay, if I'm following SADMAP, the first thing I should try to do is subtract. Okay, subtraction is the opposite of addition. So if I'm adding by 5 and I want to undo that, then I need to subtract by 5. Now if I subtract by 5 on one side, I must do it to the other side. Because that's basically the fundamental rule of algebra. Right? You can do anything you want, but you have to do it equally to both sides. Okay, so 5 minus 5 cancels out. Okay, so I have 3x left on the left. On the right side, I have 23 minus 5, which is 18. And that's taken care of. Okay, now what else is being done to x? Well, it's also being multiplied by 3. Okay, so now I want to undo that. Okay, there's nothing I can add. Okay, I subtracted already, there's nothing I can add, but there is something I can divide because division is the opposite of multiplication. So if I am multiplying by 3, okay, this tells me what I need to divide by. Okay, I need to divide by 3. And if I do it to one side, I must do it to the other side. Okay, so x equals 18 divided by 3, which is 6. Okay, and again, you should be familiar with solving for x from your algebra classes, but that's basically how you would go about it, okay, because you're going to have to do that in a lot of these problems. Okay, so pause it here if you need to look over this, if you need to practice some more. Okay, and then we're going to start doing some examples. Okay, so example 0.5. Okay, so make sure you have those 3 equations written down in your notes. Okay, because again, we're going to be referring back to these and using these 3 equations to solve the problems. You don't need to memorize these equations because I would give them to you on a test or on an assignment. Okay, but for right now, just for these examples, make sure you have these written down. Okay, so example 0.5. The question says a ball is thrown up with a velocity of 20 meters per second. As I go through, I'm looking for units and I'm looking for context clues. I know immediately that this is a velocity because, well, number one, it says velocity, and number two, it has units of meters per second. So I know that is a v, but I don't know if that's a vi or if it's a vf. Okay, so I keep reading. And it says it accelerates at a rate of negative 10 meters per second squared. I'm keying in on that unit, meters per second squared. Nothing in physics has the unit of meters per second squared except for acceleration. Okay, so as I'm reading this problem, I'm figuring out my givens. I know I have the acceleration is negative 10 meters per second squared. I have a velocity, okay, is 20 meters per second. I don't know which one yet, but I'm going to go back in a second. And here I get to the question, how long does it take? Okay, a question about how long is always about time. Okay, so my unknown is time. Okay, how long does it take the ball to reach a velocity of negative 20 meters per second? Okay, so this velocity is happening at the end of the problem, which means that 20 meters per second has to be v initial, and that means v final would be negative 20 meters per second. Okay, so in other words, at the beginning of the problem, the ball is thrown up. At the end of the problem, the ball has a velocity of negative 20 meters per second. The reason this velocity is negative, if you're wondering, by the way, is because the ball goes up, and then it stops, and then it falls back down. Okay, so remember, velocity has direction. Okay, and that's what that negative sign indicates here. Okay, so we have three givens, one unknown. Remember, you must have three givens and one unknown before you can solve these problems. Okay, so what I do now is I look at my list of equations and I decide which equation has A, VI, VF, and T. There's only one equation that has those exact four things. Okay, now you can also look and say, what did I not write down here? I did not write down delta x, so I also need the equation that does not have delta x. Okay, and that equation is this one right here, VF equals VI plus AT. Again, how did I know to use that equation? Because that is the only equation that has these exact four things. Okay, my three givens and my one unknown. That's why you need to find your givens and your unknown before you can do anything else. Okay, then I go to substitute. That means plug in. V final is negative 20. Okay, so in place of V final, I write negative 20 equals V initial is 20 plus A. My A was negative 10. Okay, so I'm going to put plus negative 10. And then T is my unknown, and so I leave my T in there. By the way, please keep in mind that this 20 and this negative 10 cannot be combined. Okay, in algebra they should have taught you that you can only combine like terms. Okay, so 20 plus negative 10t, okay, you cannot combine this. It's like adding apples and oranges. Okay, so you can't do that. Alright, so if I want to solve, I need to think SADMAP. Okay, I need to think what is being done to t. Well, number one, it's being added. It's being added by 20. And number two, it's being multiplied by negative 10. And so those are the two things that I need to undo to get t by itself, because that's what I'm looking for. Okay, so I'm thinking SADMAP. I'm going to subtract first if I can. And I can here because I'm adding by 20. So I want to subtract 20 from both sides. So let me rewrite this equation. I'm going to subtract 20 on both sides. Okay, negative 20 minus 20 is negative 40. And then on the right side, the 20 and minus 20 cancel, and that leaves me with negative 10t. Okay, so this is done. Now I need to undo that multiply by 10. Okay, the opposite of multiply is divide. So I'm going to divide both sides by negative 10. And negative 40 divided by negative 10 gives me 4 seconds. Okay, and so I am now done with this problem. Okay, so that is example 0.5. Okay, pause there if you need to look at that some more. Okay, this is a very typical type of problem that you're going to be asked to do in this unit. Okay, so we'll do some more examples. Okay, so let's move on. Okay, example 1. Example 1 says a toy car has an initial velocity of 8 meters per second. I don't need any context clues to tell that that is the initial velocity, because it says it's the initial velocity, right? Okay, so I'm writing down my givens. I'm going to write down VI equals 8 meters per second. It speeds up at a rate of 2 meters per second squared. Look at the unit there, meters per second squared. What has the units of meters per second squared? Okay, it has to be acceleration. Okay, this is why it's so important to understand units. Over a distance of 9 meters. Okay, now even though it says distance, the only thing measured in meters, right, is delta x. Okay, that is displacement. Okay, now even though technically speaking distance and displacement are not the same thing, they can be in certain situations. And so in this particular situation, they happen to be the same. So delta x equals 9 meters. Nothing else in any of these problems is going to be in meters besides delta x, which is displacement. Okay, and now the question says, what is the new velocity of the toy car after it speeds up? So my unknown is going to be v final, right? Because I already have v initial. Now remember, you have to find your givens and your unknown before you can figure out which equation to use. Okay, so don't ask like, oh, what equation should I be using? Until you have these 4 things, there's no way to answer that. Okay, now that I have these 4 things, I look through my 3 equations and I say, okay, which equation has VI, has A, has delta x, and has VF? Okay, and that equation is the one that looks like this. V final equals V final squared equals V initial squared plus 2 times A times delta x. Okay, there's my equation. And now I substitute. I plug in. Okay, V final is unknown, so I just leave that in the equation. V initial is 8, and then the equation says I have to square that, plus 2 times A, the acceleration, that was 2 meters per second squared. As you're plugging in, by the way, please don't feel like you need to plug units into the equation, just plug the values in. And then delta x is 9. Alright, and now I'm going to solve. Okay, before I solve, I'm just going to simplify a little bit. 8 squared is 64. And then if I do 2 times 2, okay, that's 4. And 4 times 9 is 36. Okay, so VF squared equals 100. Now, what's being done to my variable? Well, the only thing being done to my variable is it's being squared. Okay, so I only have one math operation that I need to undo. So what is the opposite of squared? Okay, that would be square root. So I need to take the square root on both sides. And the square root of 100 is 10. Okay, so my final velocity is 10 meters per second. Okay, and that is example 1. Okay, so you've now seen 2 pretty straightforward examples solving problems with constant acceleration equations. Okay, I want to take a look at one more example, and I want you to try to do this next one on your own. Okay, but pause it here if you need to finish writing that down. Okay. Okay, so here's example 2. Okay, so I want you to pause it here and try to do example 2 on your own. Okay, remember, start with finding the givens and the unknowns. And I will give you a big hint. One of the givens is not explicitly given, okay, but it's given to you in context clues. Okay, so see if you can figure out example 2. Pause it here and enter example 2 on your own. Okay, so the answer to this question should look something like this. Okay, and you should have gotten an answer of 31.5 meters. Okay, remember, when you plug into the equation, you don't need to plug in units. Okay, so 31.5 meters. So if you did not get that, okay, go back and double check your math. Hopefully you recognize that starting from rest is a context clue telling you that the initial velocity is 0. Okay, hopefully you got these 3 givens. That you figure out the unknown is delta x, that's the displacement, because it says how far in meters did the cheetah travel. And then hopefully you plugged in correctly and solved to get 31.5. Okay, remember right here, 0 times 3 is 0, because 0 times anything is 0. Okay, I want you to try to do one more example on your own, and that's going to be example 3. Okay, pause it here if you need to finish looking at example 2. Okay, so example 3. Again, try to do example 3 on your own. Okay, the question says, what is the acceleration of a car that increases speed at a uniform rate from 20 meters per second to 40 meters per second in 10 seconds? By the way, at a uniform rate, uniform in this context just means constant. So it's basically saying the acceleration is constant. Okay, which all of these problems are constant acceleration problems. Okay, so pause it here, try to enter example 3 on your own. Okay, so hopefully you got the correct answer, which is 2 meters per second squared. Okay, hopefully you identified these 3 givens. The unknown was the acceleration. Hopefully you chose the correct equation. The correct equation was the one that looks like this: Vf equals Vi plus A times T. Okay, but hopefully you were able to plug into that, rearrange it correctly, and get the acceleration as 2 meters per second squared. Okay, so at this point you should have an idea of how to approach these problems. Okay, for now all you need to do is begin practice. I will give you at least 1 practice assignment and maybe 2 practice assignments just to make sure you're really comfortable with this. Remember that there's not a lot in this unit. Basically all you need to know in this unit is how to solve these types of problems and then how to solve motion graph problems with acceleration. Okay, and then after that we'll be taking your test over this unit. Alright, so as always, please let me know if you have any questions, and I'll see you guys in the next video.